This is lesson 6.3, part 3. We're going to finish off question C over here. We're just about to find the maximum surface area by completing the square. We don't have a C value because, like I said, we do, but it's 0, so we don't really count that now. We can go and skip to our step where we just take out a common factor, constant factor. So we'll take out the negative from here. That'll make this L squared minus 30L. And then we can go and find the value that would make this a perfect square. So we do our negative 30 over 2 squared, which is going to be negative 15 squared, which is 225. So we can now go and add and subtract the 225. So A is equal to negative L squared minus 30L plus 225 minus 225. We can then send this outside and multiply it by our A value. And so that would give us A is equal to, so negative L squared minus 30L plus 225. Close the brackets. Negative 225 times negative 1 is plus 225. And then we can have A is equal to negative. We can factor this. So squared. Square root of 1L squared is just L. There's a minus sign here, so it's going to be a minus over here. And the square root of 225 is 15 plus 225. And so what we found is that the vertex is 15, 225. So what that means is that at 15, a length of 15, we have our maximum area, which is 225. So the maximum area is 225 meters squared, and the dimensions are length is equal to 15 meters, we need to find our W by remembering the first equation. So sub L is equal to 15 into 1 from above, which was 2W plus 2L is equal to 60. So 2W plus 2 times 15 is equal to 60. So 2W plus 30 is equal to 60. So 2W is equal to 60 minus 30. So 2W is equal to 30. So if we do 2W divided by 2 and 30 divided by 2, we get W is equal to 15. So we have L is equal to 15 meters and W is equal to 15 meters. Notice I put the units, proper units for area, proper units for the length and width. In this case, yes, it does happen to be a square. So remember, the maximum area, if you had one enclosure, is a square. In the other questions where we want to connect rectangular enclosures, you'll typically end up with rectangular measurements. So we always start off by drawing it as a rectangle, and then we see what we end up with. We saw in a previous lesson that the largest area for one particular enclosure would be the square as opposed to the rectangle for a length and a particular width. So what we've done is we've solved word problems using the vertex method. So in the past, when we were doing these type of problems here, we had to first solve to find your zeros. Then we had to find your axis of symmetry, find your vertex, find your y value using your axis of symmetry, and that would be your maximum area there. In this case, we didn't have to do that. So we did all the examples in this lesson. I do want to go back and show you that you can actually use completing the square to solve an equation as well. So we saw you can solve by factoring, you can solve by using the quadratic formula. You could find your zeros in so many ways, and completing the square is just another way you can do it. So we'll choose an example together. Let's choose something straightforward here. We're gonna solve for this one here. So I'm just gonna go and erase this, and then show you how I could solve from the completed square here. So let me just erase this, and hopefully I chose an easy enough one to do. So I'm just taking this completed square answer, and if I want to solve without having to factor, I could do like this. So when you're solving, you want to make sure that your overall equation is equal to 0. So what I would do is I would say that x, let's get a pen going here. I would say that x plus 4 squared minus 1 is equal to 0. I would then basically try to isolate for x. I would send 1 to the other side. I would get x plus 4 squared is equal to 1. And then I would square root. I would do the inverse operation there to get x plus 4 is equal to plus 1 or minus 1. Because remember, when you do the square root of something, so for example, if I did the square root of 4, that would be equal to plus 2 or minus 2, because negative 2 times negative 2 is 4, and 2 times 2 is 4. So what you've done is you've created two equations here, and you can go and solve each one separately. You can do the x plus 4 is equal to 1. So that means that your x would be equal to 1 minus 4, which is negative 3. Or you could do your x plus 4 is equal to negative 1, which means that x is equal to, so negative 4 minus 1 is minus 5. So these are your zeros here, minus 5 and minus 3. And to verify, to see if these are related to each other, let's take a look. If you wanted to find your vertex and your zeros, again, you could do minus 3 plus minus 5 to find the axis of symmetry divided by 2. So that would be minus 8 over 2, which would be minus 4. And notice that our h is minus 4. And so that works out that way as well. You could verify by factoring this to see if you had the right zeros. So again, if you had the right zeros, if you want to find the zeros by factoring, you'd say y is equal to, open your brackets, x and x. Find two numbers that when you multiply them together gives you positive 15, and when you add them together it gives you positive 8. So in this case, let's see if we made a mistake, because it seems like we may have. Did I make a mistake somewhere here? Let's take a look. So x plus 4 is equal to 1. Square root of 1 is plus or minus 1. That's right. And then I have x plus 4 in there. Right. So x plus 4 is equal to 1. And then I send that to the other side, so x is equal to minus 3. And over here I have x is equal to minus 5. Oh yeah, that makes sense. That's right. Good, we're good. So choose two numbers. So that would be plus 3 and plus 5. And when you want to find your zeros, you'd get x is equal to negative 3 and x is equal to negative 5. So it works out. I just had a little brain fart there for a minute. But that's right, so it does work out when you factor as well. And it works out when you solve by completing the square. So now you know at least 3 different methods to find zeros, and 4 if you think about them carefully. So again, you can do completing the square to solve. You can do completing the square to find your vertex alone. You can find your zeros by factoring. Or you could find your zeros by using the quadratic formula as well. So this concludes our lesson to completing the square. you should practice completing the square and practice problems that you've done previously before you knew how to complete the square, and see if you get the same answers, just to see that these tools, again, are very similar to each other, but they give you kind of different ways and approaches to solve the problem.